Righto, I wanted to do a more detailed video explanation of some of the thermal heat shielding that we've been researching into. Now, anybody who owns a sort of high performance car, whether it's normally aspirated, turbocharged, whatever the fuck it is, heat's one of the biggest things that you're going to face in running one of those vehicles, especially something with a tight sort of packaging in the engine bay where you've got exhaust pipes, especially a turbocharged vehicle where they have to duct up into a turbine housing and run very close proximity to things like brake boosters and clutch lines and even intake manifolds if it's a fucked up sort of engine like a rotary engine where everything's overlapping and very tight proximity to each other. So look, I thought it was worthwhile to do a bit of a video and give you some idea of the stuff that I've been looking into here, and it's always good to have a look at what other people are sort of doing in this sort of field. And one of the best references you can do, I mean that's some of my shit, but is having a look at what others have been doing, and one of the best ones to look at probably is in the realm of sort of Formula One, sports car racing, touring cars, that sort of stuff. So here's a bit of a picture of, some of you may or may not be aware, but German Touring Car Championship, or DTM, from a couple of years back when they actually ran proper racing engines, so 4-cylinder turbocharged, very advanced direct injected engine. And you can see on the exhaust piping here and on a proper racing wastegate and on the turbine housing, everything's shielded to stop it melting when it's tightly packaged inside a car. I mean, you know, do you have to do it? No. I mean, you can go ghetto and you can go to motherfucking Autobarn or some other shitbox supplier online and you can do like Ferrari did in their first Formula One engines, you know, with external suppliers and run motherfucking heat wrap. I mean, if you want to go full aidz, Elton John and Mung Penis, then yeah, you can do that. But does it look shit? Yes. Does it work shit? Yes. Would I recommend it? Fuck no. I mean, eventually, even these cunts, you know, end up learning and they end up using proper processes and proper materials. So, you know, that's an example of a current sort of technology of using a thermal insulation barrier, silica-based sort of fibrous insulation mat, and then the outer's just either a stainless steel or Inconel sheathing. And that stuff works really well. Here's a good company in England called Zercotech using the same sort of process to do a turbine housing. So you can ceramic coat it, or you can do a much better thermal insulation barrier, and the thermal insulation's far superior to ceramic coating. Right, so we'll show you a couple of examples here. So this is probably the pinnacle, so Formula One engine, and you can see here the same sort of processes and materials are used to manufacture the insulation. This picture I found was quite interesting. A bloke had a Formula One header and he pulled it apart, and it shows the very thin Inconel or stainless steel. It doesn't really matter. These are stainless steel strips used as bridges to allow the spot welding process to go around the piping. But you see the thermal mat underneath, and then this layer on the outside. Essentially the layer on the outside is just to keep everything together from it falling apart. I'll do some more detailed pictures so you can see there the stripping sort of, you can see where it's actually been spot welded together, and contrary to what other fuckwits say on the internet, it's not done with a motherfucking laser, it's just a spot welder. So you can buy a cheap ass thing off eBay, you know, that cunts use to do batteries, and you can spot weld it with that, or you can buy a proper professional one, and that's what I use. And you got that, and if you're not a dumb cunt, then you can manufacture all this shit yourself at home, no dramas. Here's another picture showing some detail of it. You see the seams here. This is, you know, again, it's spot welded, but this is actually done with a roller. So I've got a roller on mine, and you can do it, but we just do it with individual spots. It works fine. You can't fucking tell where you've done the joint anyway, so it works really, really well. Righto, so let's not have a look at what other cunts are doing. Let's have a look, you know, what I've done. So here's a bit of a pipe that I've manufactured myself. You know, we've sourced the material, we've got the welder. You know, we're not dumb cunts. We learned how to do it. We make our own templates to go around various pipes. We do it in a clamshell version. Some people do it in a miter. Just depends. You know, whatever gives you a hard on, you fucking do it the way you like. But it's very time intensive. So there's a lot of preparation, you know, with any sort of welding. Preparation is the key. So if you want to do a fucking kick-ass job, like that's what you're going to have to be involved with to take it on, or otherwise you just ship all your stuff off to one of the reputable suppliers and get it done. On the topic of reputable suppliers, so there's a lot of different techniques of how to do this. I want to show you a shithouse way of fucking doing it. So for any of this insulation to work, you actually need insulation material. You can't just weld the outer sleeving to the physical pipe, especially on motherfucking joins. So you can see here, you know, they've done a miter and they've physically welded one on top of the other physically to the pipe. You can see the gap here where there's no insulation on the underside. Now, this is quick, easy, you know, I understand why cunts do it this way, but it's very inferior, and I'll show you why. So let's play this little video here. Start. So this is the pipe. You can see the joins where it's physically welded on the pipe, and you watch it. You get the idea. You see the temperature being radiated through here, and the wastegate obviously isn't insulated very well, or if at all, I can't tell because the picture's a bit out of focus. But you know, so I'd say to you, steer away, or if you're going to do it, learn how to do the fucking job properly, and don't do the cunt that way, because there's really not much point in doing it that way if you're going to do it at all. This was quite interesting. So part of all this is you have to separate fact from fiction and see if the cunt actually works. So, you know, this is a very thin layer of material. It's, you know, the material itself is quite thin. Depends on, you know, which manufacturer you use, what process they use and how they do it. But the sheeting itself is all pretty similar. The gauge of it's quite thin. The insulation material can be anywhere from, you know, 5 millimeters through to 10 millimeters. And what we've found is that the thinner stuff tends to work quite well. So standard testing sort of procedure here is we've done a 90-degree elbow just to practice technique, but also to test the material properly. And what we've done is we've got our thermocouple probes. This is a dual channel, so this one will measure the temperature inside the pipe with one of my Don Mega bespoke probes that we manufacture. And we've got 2 fine wire thermocouples, one on a certified meter here and the other one on the Amiga calibrator meter, which is also very good. That's very accurate. It's backed up by this one. So we've got 2 different probes at the worst point on the pipe where the physical join is. So remember, that's where it's hardest to fit the material, the insulation material. And we just did our testing. So we ran this fucker for more than an hour on and off, and continuously testing for more than half an hour. So I think all up we probably did 2 hours, went through a shitload of gas. You see this meter, how close it is. That's less than probably, you know, 40, 50 millimeters, and that's fucking plastic. You know, we ran that there, full confidence, no dramas, nothing melted, everything was sweet. With the probes, you can see there the probe glowing red hot. This is with the gas flow turned off. And the typical sort of temperature, depending on how far we mounted these probes away from the shield, was anywhere from my previous videos showing about 230 degrees up to a maximum of 400. This was the most realistic, I thought. So keep in mind, this is a fine wire probe, this one here. That's under 0.3 of a millimetre in thickness. That's about a mil from the surface. This one's a bit thicker, but they're both ridiculously fast in processing time and accuracy. So that's less than a couple of millimetres from the surface. And I thought, fuck it. If I believe in what I'm saying and I'm going to, tell you cunts about it on YouTube, well, I'll stick my motherfucking hand on it. And you can see the thickness of a finger is what, 20 mil sort of max. Depends if you're some sort of motherfucking retard with really thick fingers, then you can scale it to whatever you want. But I'm sort of 20 to 30 mil away from the pipe there, and I held it there indefinitely, and no problem whatsoever. This picture is actually quite good for those who have no idea or, sort of don't trust anybody or anything. Well, you don't need a meter. You don't need to listen to some fuckwit on YouTube like me trying to tell you something. You just do some basic engineering and look at the temperature colour of materials, and you can infer the temperature. And these temperatures we've researched and played ad nauseum in our prior videos with EGT probes, so you can look them up at your own sort of benefit and leisure. But regardless to say that these temperatures are legit and they're proper. There's a picture of a shithouse sort of thermo rape fucking style material. That stuff's garbage. Stay away from that.
Right, so we're running the second test again just as a repeat. We've moved the probes literally, it's hard to measure, 50 degrees with 1,007 watt input, and that's my motherfucking hand. Start to tell the video I don't touch your shoe, but I'm probably 40 millimeters away, and I'm not moving my motherfucking fingers. That's how big this shit is. No dramas. That is fucking unbelievable.